let me welcome you all to this session on forecasting mass atrocities and genocide. The Carr-Ryan Center and the MARO program, the Mass Atrocity Response Operation of the Carr-Ryan Center, is happy to welcome Ben Goldsmith today. Ben is coming to us from the University of Sydney. He has his doctorate from the University of Michigan, and he also studied at Georgetown and Columbia in international relations, and has been working on this forecasting model, I think, for a year and a half with a team of other scholars. And we're very interested in your topic, and happy to have you with us today, Ben. So thank you for coming.
Thank you very much, Charlie. Thanks really for the opportunity to give this talk. We have been working for a year and a half, and actually, I think nearly 2 years now, and I think making some good progress on this project, which has at its focus not understanding all the causes and nuances of genocide and mass atrocities, but trying to create a forecasting model. So our primary goal is this forecasting ability, and our secondary goal is the social science goal of causal understanding. So for me, it's sort of a liberating project, because I'm a person who uses quantitative models to study international relations, and I am always looking for the statistically significant findings, which often don't show up. And it's been, in a sense, a relief to think, oh, all I have to care about is whether it forecasts things better, which is something that's very easy to judge, and not whether something is at the 0.05 or 0.06 level of statistical significance. So it's been an interesting project from that sense, and also something that I hope will be of use once we finalize the models and get the results out there, published and up on the website.
We're a small enough group here. Yeah. We could just ask everybody to introduce themselves and
say
kind of what their affiliation or interest is.
Actually, that would be great. Yeah.
Might help you tailor the talk about, so maybe we can start on this side.
Hi, my name is Elena Tineson. I'm a visiting assistant professor in political science at UMass Amherst.
Seth Milstein. I'm here from US SOCOM. We're your end users.
I'm Kartik Akaleshwan. I'm a first-year MPID here at HBS.
I'm Alex Zucker. I'm from the Outofsample Institute for Peace and Reconciliation, and we train policymakers from around the world in preventing genocide.
Bharati Krishnan. I'm the research assistant with the Mass Atrocity Response Operations Project. I'm Haley Lang. I'm an intern for the Modeling Project.
Adam Hill. I'm an MPA student here at the Kennedy School and UK government official.
I'm Eric Jenkins. I'm a statistician at the Carr-Ryan.
I'm David Salvador. I'm an assistant professor here.
Great. Well, thank you all for coming. And I really, since this is actually the first talk I've given on this project, so I'm especially interested in your feedback, both from the academic side, or ideas about how to improve the performance of the model, and from the end user side, what is needed in the policy world, because that's our ultimate goal.
And I will mention that we're going to put this talk up on our website, so if you want to refer people to it who couldn't be here today, it will be available on our Carr-Ryan website.
Okay, so let me launch in and tell you what we're doing and show you some of our results so far. And maybe, actually, this is a pretty informal group, and it's a bit hot in here, so maybe I'll take off my jacket. We are starting from the existing base of knowledge in sort of quantitative social science on political instability and genocide studies. we're using, among other work, the work of the Political Instability Task Force, and we're drawing theoretically from a lot of studies of mass atrocities and genocide that argue that genocide and mass killing tends to stem out of other unstable events. So whether it's called state failure or civil war, etc., there are sort of theoretical reasons out there in the studies to expect that it doesn't sort of erupt out of the blue. So we decided to do what, as far as I know, no one else has done, formally put that into a statistical model. So we use what's called a censored probit or Heckman-type models that have two stages. And I can go into why we chose the particular model we did, if you like. But we're putting both stages, the first stage getting to some unstable situation, the second stage, the eruption of genocide, into our models. And I think that's one reason why we seem to get decent forecasting outcomes. Another thing we focused on is variables that actually vary a lot year in and year out. And I've noticed in the literature, and other people have as well, that most of the statistical models of genocide and even instability have lots of time invariant variables like political systems or the level of wealth, infant mortality, which are quite powerful and useful. But I thought for forecasting whether there will be an event this year or next year, the type of political system you have is not going to be the most powerful predictor. We use all countries that have available data, which is something that has not been done a lot. Usually the sample is restricted to all countries undergoing a civil war or instability of some sort. And we do out-of-sample forecasting, which is what you have to do for actual forecasting. So in actual forecasting into the future, your sample is every year up to the present, or all the time up to the present, but you don't have the sample for the future because it hasn't happened yet. So that's the challenge of forecasting. So we simulate that by splitting the data up and say, let's pretend it's, say, 1997. Given what was known in 1997, how would our model perform for 1988, 89, etc.? We're doing some more high-tech machine learning-based analysis that's underway that I won't talk about a lot here. And I don't have any results of that to show yet, but we get at least a slight improvement from these different approaches we're using. And as I mentioned, we would really appreciate suggestions, both about the substance of what we're doing, but also the policy relevance. And I won't, I think, spend a lot of time on the details of all the variables in the model. I'll just point out a couple of things here. So the two stages of the statistical modeling. First stage, the outcome variable is political instability. And the data are annual time series data for all countries in the world for which we have data. And we can divide the variables into historical, like previous instances of instability, then political and economic variables like the change in the political system in the last 3 years, and then time-specific variables like political assassinations or whether there's an election, etc. And then the second stage of the model includes the probability of instability that comes from the first stage, and also includes some of the same and some different historical, political, and time-specific variables. So you can see assassinations, the human defense burden, the number of people under arms, percent of the population under arms, for example. So now I can show you some of, I don't have any of the machine learning results, but since I'm working with computer scientists, I can never quite spin this well. spins sort of slowly. So this just gives, this is a graphic that we'll have on the website, and it gives you sort of a view of our data, both the predictions, so the bright red are predicted events that our model predicts to be genocide onset, so the first year of the genocide, that actually are genocide onsets. But in the interest of full disclosure, we cheat a little, and if we also get an ongoing genocide in our predictions, it also turns red. But this is an interesting graphic, and you can see, obviously, Africa lights up the most. But you see, as the globe spins, the years go by. So this also, I know you can't see, but it's useful to show, pops up, just the idea of out-of-sample forecasting. So everything to this side of the blue line is in the sample, and these are all countries. Going down here, we don't have the entire list of every country in the world. On this side of the graph, all the data used up to this line are used to forecast events on the other side of the line. So this is just what our model looks like. Everything above the dotted line is an actual onset of genocide or ongoing instances where the lines have been crossed. Then I have a more accessible version of this that I'm hoping you can see a bit. So here's what we produce for use by policymakers, and you see it in a different format in a minute. A top 10 list of countries that are most at risk of genocide onset in a given year. So on this side is the top 10 list. The dots are the actual events of genocide onset, and this sort of gives you a good picture of the challenge we face, because every year you have 130, 140 countries in the data set, and not even every year do you get the onset of a genocide, which of course is a very good thing, but it's a rare events problem in statistical analysis, and it's quite challenging to forecast such rare events. But you can see it as our model goes through. Of the 9 events that are after 1988 or later, 6 of them are forecast by our model. 3 we miss, and we miss really quite badly. They're in the top 50% of our forecast, but just barely. So that's one of the challenges.
Which 3 did you miss then?
We miss, and I can show you. So we miss Sri Lanka. Here you see Sri Lanka stays black, even though even though it's above the line. And then we miss Bosnia and Burundi. So those 3 in a row. But all the others up there are in our top 10 list, which I think is a reasonable result for first cut. Yes.
Just a clarifying question. When you say that you predict onset, do you mean that the predicted probability is above 50%?
No, actually, we don't rely on the predicted probability per se, but the top 10, sort of the rank of predictions, because the actual probability of the prediction is very low. So we get a list of countries. I mean, it can be high, 0.80% or 90, but it often can
it's
be
just the
quite
country
low.
rank?
Yeah, so we just rank countries by the highest prediction to the lowest prediction. And I can show you. Somewhat visible. useful. So these, we haven't yet highlighted our top 10, but this for any given year. So if we select a year up here, 1993, you get our say top 10 prediction or just the ranked list. So these all have a probability attached to them for any given year, but we just rank them because we find that's more useful. And I'll show an analysis later of all possible prediction thresholds and how we do on that method. And so let's take a year we do very well in. So 2003, I think we have actual perfect prediction in 2003. In other words, Sudan, the Darfur genocide begins in 2003, and it's at the top of our list. And this is the only case where we have perfect prediction. But this tool we think will also be useful because it allows someone to think about the factors that turn out to be most important in our model, or some of the factors that turn out to be quite important, and compare among countries. So China is also in our top 10 list in 2003. And then you can compare some of the key variables, so the infant mortality rate, the recency of the previous genocide, whether there's political assassinations, and what we call constrained executive and increased military, increased human defense burden. So you can see that Sudan is very high on previous genocide because the genocide ended in just the previous year, and the infant mortality rate among the factors we have up here. China is higher on the other two. So this is.
May I ask?
Yes.
Are you? Whose definition of genocide are you using?
We're using the Political Instability Task Force definition. Yeah, we use their data exactly as they are.
Okay, that's Barbara Hart, right?
Barbara Hart, yes. Yes.
I don't remember, does that, I'm familiar with her paper 2003, I haven't looked at the task force site as much. So is she, so this is not including politicide?
It is, yes.
It is?
Yeah,
okay.
yeah. I have copies of the paper if you want to take it, so we're using the term genocide, so I don't always have to say genocide.
Yeah, that's fine, that's
yeah.
fine, I just wasn't sure about that. I mean, I thought so, if it was based on that. But
yeah. And another nice feature of this is if you want to get it to work, you want to think about a particular variable, you can select it and look at the countries that rank the highest on that particular variable. So it's somewhat of a useful tool to get inside the data and think about what's going on. So yeah, that's the beginning, or the sort of the alpha version of our forecasting tool, the software that we're creating. And if there aren't any other questions, I'll go on to talk a bit about performance of the forecasting model that we have so far, and then get your feedback. Okay. So no other questions about it?
I guess I have.
Yeah, okay.
I'm not super familiar with the statistical models, but from what I can tell, it seems like you're running a dynamic panel regression model where you have the dependent variable this year. On the right-hand side, lagging year, right? So instability this year is regressed on a bunch of variables, including instability last year.
Yes, yeah, that's true. We have the lag-dependent variable for instability in the first stage of the model. So the first stage of the model forecasts instability in every year, including ongoing instability. So a civil war over 10 years will have every year in the data.
For how many years do you have data?
The data go from 1974 to 2003. It's just limited sort of by the available data for the.
So you use the full sample to estimate the parameters?
No,
Or you use the pre, what did you say? Like
we use up to, up to 87
Uh-huh.
to estimate the parameters for these results, up to 87, and then so the model was sort of trained on the earlier data, and then we take the parameters trained on that data, as you would have to do if you're forecasting, and say, if 1989 or 1988 is the future, given the parameters developed by the model in the first stage, what would it say? In the earlier period, what would it say for the later period? So, but just to finish answering your question, so we use the all years of instability and a lagged dependent variable for instability, but of course we can't do that for genocide because we're predicting the onset of genocide, so we need to predict the first year only. So we put the first year in the data set. Everything else has to predict the onset of genocide, but then we drop ongoing cases of genocide because we're not trying to understand or predict when genocide will continue or when it will end, which is, of course, an important question and something we'll probably do in the next project. The duration of genocide will last a long time. Okay, so the forecasting performance, and we use the same metrics that have been used by the Political Instability Task Force. So Barbara Harp's 2003 paper is really sort of the starting point for us, and that's of course a very path-breaking and highly cited paper. And she and the later work of Jack Goldstone and co-authors, they use a forecasting metric where they say basically how many true positives they get, what percent of those do they get correct? So how many genocide onsets do you actually forecast correctly at using a certain threshold for forecasting, and how many true negatives do you get? So how many years of non-genocide onset do you get right using that same threshold? Okay, and they use sort of balanced forecasts. So with three different forecasting or threshold points, because the choice of the threshold point is completely arbitrary. 0.5, might seem like, oh, it's more likely than not, or just as likely as not. But really, we like the rankings, and you can use any threshold point. So if we want to get very balanced, we get 77.8% of genocide onsets and 79.7% of non-onset years correctly. If we move it if we put the threshold a bit lower, 88.9% of onsets and 75.1% of non-onset years, and then you can put it lower and get all of the onset years in, and we still get a reasonable proportion of the non-onset years. But I really want to emphasize that, those percentages sound high, but this metric is also not maybe a perfect metric for giving you an understanding of just how many false positives are in the data. If you have 150 countries every year and 20% of them or 30% of them are false positives, I mean, this is a concern for me since we're thinking about forecasting for policy applications. You're going to have a list of 30 countries, or 20, 30 countries, and sort of imagine what would a policymaker do with a list of 20 or 30 countries. You might have been able to come up with that yourself just from knowing a bit about the country. So we're getting fairly good forecasting performance, and when we get things right, the forecasts are within the top 5% or 6% of the countries at risk that we identify. So those 6 of 9 cases that we say we get right, they're in the top 5% of our list. So I think that's something that a policymakers could probably work with. A short list, less than 10 countries. But really, forecasting is, it's about attaching some degree of risk to each country, and that's a better way to think about it, at least in a statistical sense, than a simple list. So a measure that looks at all possible thresholds and measures how well your model does at forecasting in general. This is called the receiver operating characteristic area under the curve, which is commonly used in forecasting applications. And there is our curve. It doesn't look much like a curve because we have a small number of genocide onsets. But we get the area under the curve, which is simply this entire area here, is over 90%, just over 90%. So this sort of metric that we prefer, although it's also not perfect, but our out-of-sample forecasting for this period, 88 to 2003, is best measured by that curve. Okay, so and just to give examples of our forecasting performance and the actual lists we would produce. So I've given 3 examples here, 3 sequential years with the different types of forecasting outcomes that we get. And so for 1993 is the type that is not very good. And to give you an example of a year when we have poor performance of the model, Burundi is not within our top 10. It's only in the top 44% of the forecast years, so approximately 60, 70 countries. So in 1993, our model would not have done a good job of forecasting Burundi, but it did have Sudan and Angola at the top of the list, and which were actually ongoing genocide. And you can see the other countries were countries that you might think of as being at risk. And sort of the next step for the project, and something we've been doing already, is to think of forecasting not just for the next year, but for a certain period, 2, 3, 4, 5 years. And then it would, it'd make a bit more sense. And I think also from the policy application standpoint, you want to know which countries are in danger over several years if you're going to, say, try to extend aid or do other preventive measures. Okay. For 1994, we get quite a good result. So whereas this is not good forecasting performance, in 1994, the area under the curve here is almost perfect forecasting. So 1.0 would be perfect. But Rwanda is a genocide onset in that year, and it's in our top 10 list, and among the top 10 of 2 other ongoing cases. But then in 1995, this shows sort of the challenge of forecasting. There are years when there are no genocide onsets, but of course our model will produce a list of the top 10 countries at risk, and you can see that there's no way to say the actual forecast probability is much different in a year where you don't get an onset than it is than when you do. So in 1995, we produced this top 10 list, and ongoing genocide falls into that list. But of course, it doesn't. It detracts from the forecasting performance of the model, and that's just a sort of a necessary difficulty or challenge in the data. So just a few more words about the next steps that we're planning to take, and then I'll be happy to answer any questions, but also really, I hope, get your feedback, criticism, and comments. So with the machine learning and what's called non-parametric approaches that we're turning to just now, I've listed some specific approaches that we're taking, and one we're especially interested in is this ensembling. And I've put up this photo from the 2011 KDD Cup, and this is a classroom or a group of mainly undergraduate students in computer science in Taiwan who won this, what's called the KDD Cup, which is actually the oldest data mining global competition in the world, and it's quite a big deal. They won this, these students directed by their professor, by using something called ensembling, which is the students were all asked to create their own models to predict this particular task that was given for that year, which I think was people's choices of music on the web or something like that. And although none of them was a great expert and none of their models did very well, ensembling takes models and takes different models and in a very sophisticated way averages them to maximize their performance. And doing that, a bunch of undergrad and some graduate students actually beat everyone else in the world who was trying to win this very prestigious computer science data mining competition. So we're quite interested in that, producing a bunch of models in a sort of, in a rigorous way that keeps them separate, and then averaging. And we have ideas for more variables, especially the time variant variables. We will have a website that's up soon with these forecasting tools that I can send along. And we're thinking of ways to make the model more useful for policy applications, both the presentation and what you can do with it, and just the information that's on it. So with that, I really look forward to your comments and feedback, and thank you again, Charlie, for hosting.
We're glad to be the first place where you've unveiled this project publicly. Any questions or comments for Ben?
Thanks for your talk. I teach on various issues of international security and genocide and international justice, so I'm always looking for new material for teaching purposes as well. My question, I hope this doesn't seem unfair, and I don't want to get into a big epistemological debate about why we do what we do, but clearly the starting assumption of any project like this is that advanced warning and more knowledge will help in the prevention and response aspect of this. And given that your support's coming from a responsibility to protect related project, and clearly this is part of it. So when we look at some of these past cases, what is it that suggests to you that if we had some more early warning, that this would change the policy responses to this? Do you see in the empirical story of this that there's a need for that? And again, I'm sorry if that seems unfair, but it seems that's clearly the starting assumption of any project like this.
Right. Well, I mean, I do. So I assume, and we argue in I think the first paragraphs of the draft paper we have, that a early warning would help in two ways. One, focusing on particular countries to gather information about which countries are more at risk. And I certainly wouldn't want to argue that you should only use my model. Of course, all the country expertise or whatever expertise that already exists, whatever other forecasting models that are in use, but I think we have, at least for forecasting genocide, this model, I believe, outperforms other models, certainly in the published literature. So it will give you at least one rigorous tool to focus your attention on countries for collecting information. And one of the arguments that we make is if there's going to be, say, intervention on R2P principles, it seems like you need the information, the evidence of what's going on. So it might, I mean, one of the challenges seems to be that countries, if they say we don't know exactly what's going on, we didn't really know that Rwanda was going to blow up. If there's an incredible amount of evidence because NGOs or governments have focused on that country, we think that might be one application. If countries are genuinely interested in preventing genocide, then obviously having this tool at hand we think might be another, because in these cases things could have been done once we produce our 2, 3, 4, 5-year forecast. If you focus on the top 10 countries in the list 5 years in advance and try to have either focus on groups that are actually at risk or focus on make it clear to leaders that mass killing is not something that is going to be in their interest, that may help prevent. But with that said, these are my ideas as an academic, not a policymaker. So I believe it will be useful. The R2P fund in Australia seem to agree from our grant application, but I would also love to hear suggestions about how it might be useful. I think not having this information couldn't be an advantage. It might. I believe it will be useful, but it's not having it wouldn't be more useful.
I had asked a variant on that question of Ben when he was in my office, in the sense that I was working with a human rights organization monitoring Rwanda pretty carefully, and we knew pretty much the human rights community, I think, knew 60, 90, 120 days ahead of time that something very bad was going to happen there, and couldn't get the international community to kind of rise to the occasion. And so I think it's a very interesting question. How does the international community, and I know that's a very vague term, respond to these situations when we are pretty certain that some terrible things are going to happen? Hopefully R2P gives us some advantage in that. Yes.
Hi, 2 questions. First one, you mentioned the next stage in your work is going to be looking to do the sort of 2- and 5-year forecasts. I don't know how far you've got with that, but I was just wondering if you had any either early evidence or ideas about whether different variables are going to be key. If we're looking 5 years out, whether we need to be sort of thinking about one particular set of variables, whereas, if it's something more immediate, then it's things like assassinations or something much more time-specific, which are the real keys. So I just wonder if you had any thoughts in that field. The second one is sort of more related to the policy application discussion, which is around if something like this is to be useful to policymakers, obviously it needs to be out there and be known and widely used and kind of and visible. I just wonder if you had any thoughts about how to get it from being a useful tool to something which is really widely known and shared across the sort of government NGO space.
Yes, well, to your first question, the answer is sort of yes and no. Yes, we have run the models for 2, 3, 4, 5 years using these data and an extension of some of the variables. One of the interesting variables we have in there is elections. And elections you can know, in most cases, when they're going to happen in the future. So we put future elections into the model. But the part of your question that I can't answer yet is which of those variables is more powerful. We haven't examined either whether the variables that are in the model now are more powerful predicting 5 years ahead, or whether other variables that we might add are more powerful. So we're just at the initial stages of that. But yeah, interesting question to think about whether some variables are better for forecasting farther in the future. And just in spreading information about the model or making it aware of it, we will, by the end of June, when our project is supposed to end, we will have our website up with these policy relevant tools on it. But I'm also doing talks. This is the inaugural talk, but I'll be presenting this at the Council of Foreign Relations in DC and at the International Crisis Group and other places in Europe, at RAND Corporation later on this year as well. So we're trying to get the word out. We're going to have reports as well that describe our the forecasting performance of the models and also how they're constructed, but in a way that's not technical. And we'll produce those. We have to produce them by the end of June for our final grant report. So we're rushing to produce those now. So we have plans to disseminate the information, but also very interested to hear what might be effective ways to do that, more effective ways.
Thanks. Thanks a lot for your talk. And I mean, you know, so we are the organization I work for. We do one-week seminars for mid-level government policymakers, and we bring them to Auschwitz for a week. We teach them about genocide, its history, the processes, and some of the policy approaches they can use to prevent it. And then we're building this network of policymakers to keep in touch with each other, to share their experience and information, knowledge, and all of that. And so I've been reading a lot in the last 2 years, and I will admit I don't understand statistics yet, at least. But I'm interested. I think early warning is one of those things that's necessary but not sufficient. I mean, I think what's obvious is it always comes down to this question of political will, and different people have different ideas about what that means. But my understanding of one of the big problems with Rwanda, for instance, was that policymakers knew what was happening, but they were viewing it through a civil war lens rather than an atrocities lens. So they were focused on this, the peace talks that were going on over in Tanzania instead of what was actually happening in the country, and looking at it as two sides vying for power as opposed to one side wanting to slaughter the other. And in spite of the history of genocide there a couple decades earlier. I was wondering, so just some comments and some questions. So I was wondering, I read something recently that the U.S. Holocaust Memorial Museum put out. They had a conference in October last year. Do you know what I'm talking about?
Yes, yeah.
So I thought that was really interesting. What I got out of it was a lot of the improvement in statistically predicting true positives produces so many more false positives that it may not actually be helpful. And they were, and the paper that I read was also saying that this is especially a problem when you're talking about presenting this to the public. And it's hard for, I think, the average person, including myself, to grasp, there has to be some explanation about what are the limits of this approach, so that people, because your average person, it sounds great, but I was thinking about the weather, like you can tell people what is the chance of rain, but how do you make sure that they bring umbrellas out, right? I mean, that's the issue, because some people are going to say, well, it says there's a 70% chance of rain, but I don't want to bring my umbrella because I have this big bag full of all this other stuff. What's going to make me bring out my umbrella? A couple other thoughts. If early warning factors from a policymaker's point of view could somehow be more explicitly connected to approaches of prevention. In other words, the toolbox, as we call it, is relatively small. There's no revolutionary ideas about how to prevent genocide and mass atrocities. But if there was more effort to connect certain approaches to certain types of risks, I think that might strengthen the likelihood of them being put into place. Does that make sense? Mm-hmm. Obviously, like what's happening now is governments are more and more setting up focal points or places of sites of accountability in the government, which greatly improves the chances that something will actually happen, because if nobody's responsible for taking action, then they can't be held accountable for not taking action. So this will be useful for them there. And then I guess sort of connected to that, I know the U.S. government alone has, I don't know, there's a dozen watch lists. So I guess then the question is, maybe this ensembling thing we were talking about is a productive path to go down, because, you know, one of the problems I see is that there's so many watch lists. I mean, even in that, just, you can go online and, you know, I run a forum for our alumni, and I have a site on our forum, you know, a list of watch lists. I mean, these are public, you know, NGO watch lists. I mean, there's dozens of them. So they all tend to have the same countries on them. I don't know, these are not probability associated, right? So, we know that that, you know, country experts themselves are going to produce a lot of these. So, yeah, how do you connect it to actual approaches to prevent? So those are just, these are really scattered random thoughts.
No, but I really appreciate your feedback and these thoughts, because I think they're quite useful for me and us as we think of applications. I guess to start with your last point.
Sure.
If watch lists are produced with some sort of statistical model, then we can use them in the ensembling approach, and that would actually be great, because the power of the ensembling approach comes from having really different models with different assumptions. But as you say, the lists that I know are more, even like the lists that are produced by Barbara Harp and others for future forecasting, simply examine the values of the variables that she has noticed in the past from her statistical models. But one of the papers from the Holocaust Project by Chad Hazlitt points out that
it wasn't that good at predicting.
Well, yeah, and her model is not actually an annual forecasting model. The model that she has published, although he turns it into one, which is quite useful. So that could be done, but most lists don't have those models behind them, so we couldn't put it into a bigger set of models, unfortunately. We'd have to create a model that produces the list, which is probably harder than this. But that's an excellent idea. We can combine other models that are out there. The other issues, presenting forecasts in a way that says, get out the umbrella, or here are cases that are in need of some preventive action. That's what we try to do with these top 10 lists. And given the performance of the model, we could actually turn them into top 6 lists. In half the years or some number of years, there would be no country that would actually have a genocide onset, thankfully. But we can, based on our model, when we're wrong, we're very wrong. And so but 2/3 of the time we're right. And we could give you a list of 6 countries, and we could say that when there's going to be a genocide onset, 2/3 of the time that onset is going to be in this list based on the past performance of our model. In the same paper from the Holocaust Museum Conference, it's pointed out that there may be a change over time in the frequency of genocide, that it's getting less frequent, which is great, but it would mean our lists, of course, would be wrong more and more, since if there's onset less and less, if that's a general pattern, although it's certainly not decided that is a general pattern. Connecting prevention approaches to the particular forecast, that's something I haven't thought about at all, and that's an excellent idea, probably for the next project. But based on what makes the country at risk, or what characteristics of countries, what would be the best approach.
I haven't ever seen that done by anybody,
And I imagine
from a policymaker's point of view, that could be useful.
Very useful, I'm sure. I imagine it's a whole another field, sort of at least of academic expertise. What's the best way to prevent or stop an ongoing genocide? That would seem to be a big question.
I may just intervene here in case you aren't familiar with the MARO project.
Oh yeah, we use it in our seminar.
Oh, terrific. And the fact that MARO has gone from kind of the idea stage to the development of a policy planning framework, and is now actually has an office in the DoD called MAPRO, because they've added prevention in there, is going to be terribly encouraging in terms of how quickly that took place. And I think there's a lot of interest, am I right, Bharati, that some of the NATO countries and other countries are looking at MAPRO as their own policy planning frameworks as well. So.
So just to be clear, I think I may have missed this at the beginning. The types of events that you're looking at are specifically genocides and politicides, but not atrocities if they don't constitute a genocide or politicide? Because normatively and empirically, there could be a huge difference between the two. You know, like we know that there's atrocities in Syria, but nobody's calling it a genocide or a politicide at this stage. Same thing with contexts like Kenya or Cote d'Ivoire, etc. Because genocides as well have certain causal dynamics that maybe other types of atrocities wouldn't have. We're looking at ethnic divisions in societies and other types of communal divisions. So would that be like a separate set of cases for you, or is that included as well?
The short answer is yes, separate set of cases, not just mass killing that is aimed at a particular group. So it's by scale of killings as opposed to. So there is a series of papers, a book by Benjamin Valentino, that you may be familiar with. So he focuses on mass killings, and he has a number, I believe it's 10,000, but I'm not sure, beyond which, once that number of people are killed, it falls into that category of mass killing, even if it's not a particular group. So in the genocide studies literature, I know there's this huge debate about intentionality and about what's a group, and these are all very difficult questions. I mean, that I certainly recognize, and that one of the reasons why we use an existing definition with an existing data set is not because we believe that's the one true definition or the best data set necessarily, but at least it is a consistent data set that categorizes genocides or politicides according to a single definition. And I think, as you say, the argument that there may be a different causal process when a group is targeted, and it seems like extermination is the goal, in part of the goal, then that may be something different than mass killing. But I see definitions as tools that we can use to answer particular questions, so I'm also quite interested in extending the model to other, using other definitions, data coded according to other definitions.
Because certainly, the more narrow definitions of genocide wouldn't give you much data to work with either. And ethically it poses a policy problem as well, because you don't want to say, that below a certain level of killings, it doesn't matter in terms of policy responses, or the character of who's being targeted or whatnot. So.
In the Political Instability Task Force data, I began by having a threshold of 1,000 deaths for a genocide, and I noticed there were several cases that had less than 1,000 deaths that are categorized as genocide in the data. I thought that was interesting, but for reasons both to have more data for the modeling, but also because it could be that the numbers are less certain, and because it is categorized as a genocide under the definition. We put all the PIT of genocides into the analysis, but there's some that wouldn't meet big numerical thresholds for people killed.
I'm going to ask one of our audience a question. David has done a study in Rwanda about where hate radio was blocked by physical barriers, so that there was problems with transmission, and documented that there was significantly less mortality in those areas where the signal was blocked. This is kind of a long-term model in a way that might present heightened kind of awareness of some places. And I suppose that kind of another step might be looking at, okay, this is a long-term predictor. What are the short-term predictors? Do you see a rise in hate radio? Do you see kind of a rise in the use of the media to other certain part of the population? So that there might be within the 6 countries that you think are on the watch list, might there be short-term models that could then allow you to even be more concerned?
So following up on that, I'm interested to hear sort of, I understand you're now moving into machine learning, so, but what was the selection, how did you select the independent variables? Because I can come up with 10 or 20 other variables that hypothetically could affect conflicts, right? And so you chose some particular set, and I'm interested in sort of understanding what you chose.
Okay, well, I mean, first, I'm actually really interested in learning about your work and because it's, we're really interested in getting very time-sensitive indicators, as I mentioned before, so I hope I'll have a chance to talk later. But getting the independent variables, well, we've been doing it for a year and a half. The short answer is just a lot of reading and work and trying things. But we went through a process where we surveyed the literature and got all the variables that were in the literature that might be useful in explaining either instability and or genocide. And so, I mean, it's a very complicated process, and we tried to do it systematically, but I can't tell you it's 100% systematic in the way we evaluated every single variable. So I think there's more work to be done now that we have a model that seems to do well, I think seems to do out-of-sample forecasting decently and at least as well as anything else I've seen, to go back and think systematically about some of the other variables that we sort of discarded up to now. But so we surveyed the literature and then just theorizing about it, thinking about it as well. So things like elections, I just thought we really need a time-sensitive variable, and looking at violence surrounding elections in many recent elections like Iran or Kenya. It seemed to me that, and reading through the actual cases of genocide in the data set, often they occurred around the time of elections. The interesting thing about elections, this is not the only variable that turned out this way, is that they had the opposite of effect to what we expected, and we're working on another paper about elections and instability. Actually, elections tend to reduce the chance of instability, but only in highly ethnically divided states, according, in our best models of them. So we expected elections to be connected to more violence. It turns out, in general, according to the models we've done there on. So it's been a long process to get the independent variables, and that's sort of I think the strength of the model so far, because it's not a fancy new statistical technique. It's just Heckman probit models, which have been around for decades.
So, it depends a little bit on what the ultimate goal is, I guess. But if it's just forecasting, at some level it doesn't really matter what kind of independent variables we do. We just care about getting the prediction right. So, if it's elections, or if it's food prices, or if it's, number of newspaper articles mentioning, deaths, or, it doesn't really, on some level, it doesn't really matter as long as you just get those predictions right. On the other hand, it seems, from a policy perspective, if we see a high predicted probability of onset, sort of the next step would kind of be, well, what's causing this high probability of onset? And so there's a set of factors that affects the probability of conflict. We sort of want to understand which factor it is.
Well, that's what I think would be useful to connect it to approaches to prevention.
That's right.
That's what you're getting.
But then I think you're facing a trade-off, which is then you can't just be including as many variables as you'd like on the right-hand side of independent variables, because then you're going to get very noisy estimates of each independent factor. And so I think there's this trade-off. I don't know if you've thought about this probably a lot more. It seems to be this trade-off of being a very good predictor and then being good at explaining why the likelihood is higher. Do you see what I'm saying?
Yes, and I completely agree. And I'm acutely aware. I mean, the variables that we have in the model, we have several interaction terms
Oh, you do?
But we don't include the first order terms because they don't help with forecasting. But I would never get this paper published in any journal if I tried to interpret that.
Right.
Because
It's
it's not kosher statistically.
Yeah.
But it produces a better forecast. And our argument is that these are very complex phenomena, and the perfect model will have perfect understanding. Every variable that should be in there is in, no variable that shouldn't be in is not in, and it would have perfect prediction. But since we don't expect to get that, we are focusing primarily on forecasting, but then yes, for the policy applications of what to do or what is the cause, the models might give some direction. This variable really looks like it's the most powerful, but you would want to then have the proper social science and especially qualitative case studies. Examine the actual case.
Right.
Does your correlation actually lead you to a story that makes sense in that case? So I completely agree, and thankfully there are many people working on genocide studies, and in terms of what this work contributes to that, I hope the decent forecasting performance will maybe provoke people to think about some of the variables that we've included and try to understand better what's interesting about these variables, that are new to models.
So, I also have even more technical comment, perhaps, which has to do with when you estimate the parameters of the model using the pre-1988 data. You have about 12 years of data, something like 13 years of data, and a large set of countries. And my understanding from the statistical literature on dynamic panel regressions is that we get bias estimates if the time period is low relative to the number of countries. And so there are statistical ways of correcting for biases in the parameters. So there are two methods. So I don't know, and that might help you then do even better predictions if you have a bias in your estimate. So I don't know if you looked into those correction methods. Already on a bomb correction method, for example, Anderson shell. Are you familiar with these correction methods for?
No, I've used the political science econometrics literature that I know on what's called time series cross-section data with a binary outcome. And so I'm working with the best statistical advice sort of in my field and from computer science as well. So I think...
But you have serial dependence in the...
Yeah, so we're doing everything we can, everything that we know to correct for that, but I'd be glad to get your advice as well.
I think the necessary assumption for there to be consistent estimates is that the number of time periods is large. And when it's low, things become more shaky. So yeah, we can talk about that later.
Well, let me thank everyone for coming today and mention two things in case you didn't get it off the announcement of the event. That Ben mentioned that this can be found on the Asia Pacific Center for Responsibility to Protect. So if you want to kind of look at this model, that's where it's going to be posted for information about it. Is that right?
It will be linked, and it will be housed at the University of Sydney. And we will have the website up by June, and we hope to.
And if you'd like to kind of have a conversation with Ben and go a little bit deeper, he's going to be in our faculty director's office from 1:30 to about 3 to meet with people that want to talk a little bit more in depth, and there'll be a few sandwiches there. So feel free to come by if you want to kind of dig in a little bit deeper. Ben, thank you very much.
Thank you very much, Charlie, and thanks to you all for your really helpful